Well, howdy, physics sleuths and inquisitive souls. Welcome to another edition of Dynamic Gravity. Um, I've been thinking long and hard about the math that I've made for dynamic gravity and how to fix it. And I think I found a fix that at least brings it into much better tolerances, what I like, but it definitely is not 100%. We'll go into that right now, though. I'd just like to apologize for my voice being a little hoarse right now. I got in a fist fight last week. The dude sucker punched me and elbowed me in the throat, and it really messed me up. But don't worry, the fight only lasted about 20 seconds, and I won. Definitely won. He was begging very hard for me to stop, but when you sucker punch me, I don't like to play fair. I'm sorry. So, moving on to more important business. Let's take a look at what we got here. So, according to dynamic gravity, if you don't know how this theory works, I highly encourage you to go back and look at some of my original videos explaining the whole thing in a simplistic way. But basically, magnetic fields, electric fields, and gravitational fields are all like kind of brother and sister, sibling forces. Um, so you would expect gravity to operate very similar, if not almost identical, to a magnetic field. Of course, gravity affects all matter, where magnetic fields only affect matter that has like a what is it? I think one lone pair electron in its outer orbital shells, valence shells, which causes the magnetic field, if I'm not mistaken. But magnets put out a field, right? So do celestial objects. So does everything. Gravitational field, magnetic field, it all kind of looks similar. Only magnetic fields are, bipolar, where gravitational fields would be more like monopolar. So that's definitely one difference right there. That'd be kind of odd, but let's just say that because they're brother and sister force, they're going to behave somewhat the same way, which is a very, very reasonable and plausible thing to conclude. I realized that when you have two magnets together, the magnetic field lines change. The other magnet changes and alters those magnetic field lines. And if you get, to the point where the magnets are not touching but very close, you can have like almost half of the magnetic field lines squarely just going in between the two magnets, reinforcing the strength of the magnets. And it's you can't really see it right here, what's going on, but it is. If we look a little bit better, you can kind of see this is a good diagram to kind of show you how the magnetic fields kind of interact with each other. When you put two magnets together, it changes the fields. It compresses and squishes and elongates them and, diverts them. It just moves them around. It exerts force on them. Here's probably a really good, here's just, just something, describing this effect quickly and showing you, various possibilities of what could happen. But as you can clearly see, this definitely happens in physics. When you have two magnets together, it changes the magnetic field. It alters it. So I'm thinking this also is occurring on a gravitational field, which would mean that if you have, let's say, a planet with one moon around it, let's go here. A planet with one moon around it, like the moon, right? The Earth and the moon, you would expect it, if my math was correct, to be around 1 for the modifier, the gravity modifier. I made a whole video explaining all this math and how I got to it and what it all means. So if you haven't seen that, definitely go and take a look at that so you know what this page represents and how much work went into it. But but yeah, so we got the modifier would be about 1 when things are in equilibrium, which they should be unless there's other things messing up the system. And that's what we see when we see just like single moons, like the moon and the Earth. Phobos, I believe it is, orbiting Mars. I probably should calculate that too. I did it before, and it was actually a very positive number, meaning that it was way too close for equilibrium to Mars, and it is a very close moon to Mars, only being like, I don't know, 1,000 kilometers away from it. It's very close. Maybe not 1,000, but it's very close moon. And I think that was like, I don't know, 1.8 or 2. I have to redo the math to remember exactly, but that's kind of an exception. But it just tells you that system is definitely not in equilibrium. But we got other systems, right? Like Jupiter, the main moons of Jupiter. There's a lot more. These are the main ones. And if we add them all together, it does work out to be actually over more than 1, meaning that Jupiter is also not in equilibrium, but that could be because the more planets you have, the less likely you're going to be in equilibrium, the more moons you have. My bad. I believe these are the moons of Saturn, and it's the same deal. If you add up all these numbers together, the modifier from this equation right here. I'm pretty sure I can show you the equation at least. Yeah, from this equation right here, which is a derivative essentially of Coulomb's law, which would be somewhat valid if my theory of how gravity operates was correct. Then yeah, these ones also, if I'm not mistaken, add up to about 1, maybe a little more than 1, like 1.5 or something. I'd have to redo my math. I did it like a week ago, checking all this stuff out. So if that was what was going on, you would expect that when you add, all the celestial objects orbiting a larger celestial object, like a parent celestial object, it would equal out to be more or less around the neighborhood of 1. And it's definitely not, coming out to be exactly equal to 1. There's definitely some wiggle room, but when we're talking about astronomical numbers and astronomical objects in space and the distances that they are, any formula that you have, if you're looking for a 1 and it comes up to like a 1.5, that's really good. That's insane accuracy if you think about it. So yeah, I added up all the MGs here, a modifier of gravity, for everything that was affecting our sun, our star. Since this is our local little neighborhood of our planets and moons and our a couple stars around us are really the best things we have that we can estimate the gravity strength or gravitational acceleration for those stars, and objects. We don't know for everything, at least not to my knowledge, but we do have it for a lot of stuff. So just adding everything up, numbers, like say the Earth, we're looking for a 1, instead we get a 0.001. So that is like about 0.1% of the number we're actually looking for to truly be in equilibrium, which we want to see, because I'm really good proof of this theory. When we add everything up together, as these as kind of like as though it was, different magnets orbiting a magnetic field, and how it was affecting the lines, and how they all add together to contribute to the total strength of the magnetic field. This is the number we get, and it's still off a little bit, but it is definitely looking much better. This is adding up all of the planets. This is adding up all the moons. This is adding up all of or not all, but just the closest stars near us, and just maybe even our galactic black hole center and Andromeda's as well. So it's really a lot of stuff that I'm missing out on when you think about how the galaxy, our galaxy alone, has like, I don't know, 1 to 200 billion stars, they estimate. So I mean, you times that even by a small astronomical number, and it's going to give you a rather significant amount of force that's going to be acting on this. I haven't done all those equations yet because I would just be estimating. And right now, I just want to deal with what numbers I know I can deal with and see if it's creating the right pattern. And it is. It is creating the right pattern. Instead of us being off, with some of these numbers, like the Earth, like I say, 0.001, now we're 0.0075, which is a lot better, a magnitude of like 7 orders better. And the further away from the sun you get, the better it's going to look, because the weaker these are going to get. So I don't know if this is totally working out the way I want it to, this math. I'm just trying to salvage it. I'm trying to use tricks to justify the numbers that I'm getting. And so far, this is the only thing that I've come up with that I'm happy with, that I think is pushing things in the right direction. But these numbers are still much further off than what I would like. So things are definitely not working the way I think they are, if this is accurate math. Which, that's to be debated. I'm not so attached to these mathematical formulas that I've derived and created that I think that they're right per se, but I definitely think they could be right, enough that I'm going to keep spending time and trying to work out a solution to make these work out the way I want them to, or the way that I think they should. But as of right now, they're resisting. So there's that. Just to give you an ideal of kind of like what these lines, or what would be going on here. Let's say we got a celestial object, right? And let's say it's got like a gravitational field, right, on it, and it would be coming out always, very similar to a magnetic field. Well, if you were to put another celestial object here, say we delete this, go back here, have another celestial object here. Now, all of these are going to be shifted over, but there's going to be a lot of gravitational field lines that are now going to be, operating kind of like this. And that is going to affect, let's say, if this one had another object that was orbiting around this one, the gravitational field that's being pulled on this is is also going to be affected whenever it's in the vicinity of this, because the gravitational field lines are going to be altered, and hence the force that those gravitational field lines can possibly exert is going to be altered as well. So it's kind of an odd concept. Magnets do it, but it's not a well thought out thing. A lot of people don't think about that when magnets are doing it. So I don't know. Like I said, I just came up with this like last week, and I've been, throwing it around my head and playing around with the numbers and just trying to see, what it does to my theory of gravity. And it definitely, it seems like this is how gravitational field will work, and it definitely helps out my mathematical numbers astronomically by a factor of like 1,000, depending on how deep we're going. But it's not a complete fix. There's still a lot of stuff going on here that I don't fully understand. I may never fully understand it. I'm gonna try my best though too. I'm gonna do whatever I can. So I just thought I would share that with you guys that are actually interested in alternate theories of gravity. To kind of track the progress on how dynamic gravity is doing, how things are coming along. I'm not done. I got a long ways to go, but I'm determined. So I'm not giving up yet. Not until CERN comes back and says that antimatter behaves the exact same way as matter. Until that day comes, which may be very soon, I'm never going to give up on dynamic gravity. And even if that day does come and that result does happen, I'll try and think and see if maybe there's something funny going on to explain it. But that'd be a pretty huge deal. So I'm excited for that day. But with that, I bid you guys adieu. Have a good day. Thought I'd share this new concept and what I've been working on this last week or two. Adios. Have a good one.
Like, subscribe, submit.